In this video, we're going to look at some helpful hints or tricks that you might use often when establishing identities. For this first example, we're going to rewrite the left side in terms of sine and cosine and then simplify to try and establish this identity. So when dealing with something like this and trying to establish an identity, we have to remember that we are only allowed to manipulate one side, and we have to prove that one side is equal to the other. We can't manipulate both and show that the left side is equal to the right side when it's manipulated. We have to manipulate one and try and get it to the other. And then typically we start with the more complicated side and work to kind of simplify it down to be something that's a little simpler. So I'm going to start with the left side, and I'm going to kind of follow these directions that it said to try and see if we can get to the secant of theta. So it says rewrite everything in terms of sine and cosine and then simplify. So I know that the tangent of theta is the sine of theta divided by the cosine of theta. And that's being multiplied by the cosecant, which I know is 1 over the sine of theta. Now, when we take this product, we can do some simplifying here. So the sine of theta divided by the sine of theta is going to be 1. So that's just going to simplify down. And then we're left with 1 over the cosine of theta. And we know that 1 over the cosine of theta is just the secant of theta. And so we got what we were looking for, right? We had to show that tangent of theta times cosecant of theta was equal to the secant of theta. And through just some simple manipulation, we've done so. So this is what it's going to look like when you're establishing an identity. You're going to manipulate one side, do some little tricks or changes to it to try and simplify it down to be equal to the other side. So let's take a look at another example. In this example, it's saying to multiply by the conjugate and then simplify to establish our identity. So we have cosine of theta divided by 1 minus the sine of theta equals the secant of theta plus the tangent of theta. So what I'm going to do is I'm going to multiply this left side by the conjugate of the denominator to try and see if we can get to secant of theta plus tangent of theta. So let's go ahead and rewrite this. So we have the cosine of theta over 1 minus the sine of theta. And we're going to multiply this by the conjugate of the denominator. So remember, the conjugate is just the same terms, but the opposite sign in between. So 1 plus sine of theta on top and bottom. Now, when you do this product, when you multiply these, we're going to get a difference of squares, because remember, conjugates multiply to be a difference of squares. In the numerator, I'm just going to leave it I'm going to leave it factored. So I'm not going to distribute through. So we have cosine of theta times 1 plus the sine of theta, all divided by. So 1 times 1 is 1. 1 times sine of theta is sine of theta. But then that's going to cancel with negative sine of theta times 1. And then we're going to have negative sine theta times sine theta, which is negative sine squared theta. 1 minus sine squared theta is one of those Pythagorean identities. 1 minus sine squared theta is just equal to cosine squared theta. So we can substitute that in. So in the numerator, we have the cosine of theta times 1 plus the sine of theta. All of this divided by cosine squared theta. Now, cosine squared theta is just equal to the cosine of theta squared. So we can cancel one of these cosines here with one of the cosines in the denominator. We're just going to be left with a cosine of theta in the denominator. So now we have 1 plus the sine of theta divided by the cosine of theta. And we need to try and get it to secant of theta plus tangent of theta. So we see that it's two separate terms, and we just have one quotient here. So what we're going to have to do is we're going to have to break this into two different pieces. And luckily we can do that because we have a sum in the numerator. So basically we can just split this into two fractions with the common denominator. So we can split this into 1 over the cosine of theta plus the sine over the cosine of theta. Because now these just have a common denominator, if we were going backwards, we could put these together and it would just turn into what we had before. Now we know that 1 over the cosine of theta is the secant of theta, and sine divided by cosine is just the tangent of theta. So now we have shown what we were trying to. So secant of theta plus tangent of theta, and all that came from this. And then again, what we had to do to get there was multiply the numerator and denominator by the conjugate of our denominator. Remember, this is just a fancy way of writing 1, because it's just it divided by itself.